So, do you hear me? Yeah? Okay. About this talk, it's a new talk based on my previous experience when I started to learn Python, CPython, not the language, just the interpreter. The previous talk was exploring the Python interpreter. But I wanted to continue this adventure with CPython. Why? Because I am a beginner and I would like to become a good contributor of CPython. Maybe in the time I will be a core dev, but just to start with a contributor. My name is just Stéphane. I come from Belgium. Okay, that's a very long travel to come here just for 30 minutes of a talk, just for that. I received a CSI, just a community service award from the PSF, because in Belgium I tried to create a community, a Python community, and sometimes I have created a new event in Belgium, the Python FOSDEM. It's a small room for the FOSDEM. FOSDEM is just the biggest event in Europe. For the developers, we are 5,000 people, okay? And I have a room with 500 people, just in one room, for one day. I'm also a member of the PSF and of the EuroPython Society. So I will have maybe a talk about EuroPython during the lightning talk session. I have one question. Firstly, are you sure that you want to stay here? Because I have 90 slides. If you want to get out, let's know. Okay? So maybe I'm going to be quick with my slides. Firstly, about the agenda. The agenda, I'm going to explain what's a bytecode. Okay? I know that there was some talks about the bytecode in this conference, but I'm going to show you another approach. Secondly, I have my Python code, how to convert it to the bytecode. Just that. That's really easy. Thirdly, what's a bytecode? Okay? Really, the bytecode. Not just, I'm going to show you the this model with a string. No. Where is stored the bytecode in a PIC file, and how can we parse it? And the last time, the PyC file. You know, when you compile a Python file, you have a binary file. What's that, really? And of course, the virtual machine. Why? Because we have the bytecode, and we want to execute it with a virtual machine. In this case, I'm going to explain some parts of the virtual machine. So, bytecode. Hey, Doc, what's that? Firstly, the bytecode is just some instruction to follow. Okay? Secondly, used by a virtual machine. I'm going to give a small example. First example. I am in a restaurant. I would like to order one thing. Firstly, I would like to say hello. Say hello. It's a bytecode. Secondly, I'm going to assign my command to a variable. And for the next, I'm going to order my command. I'm going to prepare my money. Just wait for 5 minutes. Next one, just receive my command. Maybe pay and eat my command. I pay the restaurant and eat my food. Okay? Just with that. It's a bytecode, a small bytecode, a human bytecode. Okay? Just a human bytecode. So, in the next slide, I'm going to explain how we translate the code, the Python code, to the bytecode. Just with the lexer, the parser, and the compiler. Okay? But we have to know some bricks. When you start to write your Python code, you use a Vim or just Emacs, and you start to write your code. I'm the developer. I'm write my code. I'm using the Python interpreter will use the lexer and the parser. Okay? This parser will generate an AST, abstract syntax tree. After that, this AST will be used by the compiler and will execute some optimization on the AST and on the bytecode, mainly on the bytecode. Okay, after that, maybe I will store the bytecode in a PyC file, okay? And this PyC file will be used by the interpreter later. So, some example. I have my expression, just 2 more 2. It's a simple expression. I think that a baby can learn that. My lexer will take the expression, the statement. From this expression, I will receive a list of tokens. Okay? You can see the result. I will have this list of tokens, and from that I can try to construct a sentence for the compiler. For the compiler, and this construction will be done by the parser. The parser will receive the tokens and will generate an EST with the module, the body, the assign, some component that you can use directly in the EST. So we have the parser. I would like to execute it, the code. For that, I'm going to use a compiler. This module is not the compiler. It's just a tool where that you can use to convert your source code to the bytecode. The bytecode will be used by the virtual machine later. Okay? But I don't want to explain the bytecode after this slide, just later in another section. So today we'll see the PyC file format. You know this binary file that there's this binary file in your system and you don't know how to use it. I'm going to explain you. Why? Because I would like to, just for me, because I like to learn. I wanted to understand what is this PyC file format. Okay? But in the documentation of CPython, there is no documentation about this part. Yeah, you can find some example on GitHub or just with the ByteRunner software from NetBachelor. You can see that it will open the file in binary mode and will read some part of the file and will use the Marshall module. So in this case, in this slide, I don't want to use the Marshall module. I would like to use a PyC file with Python, with Golang, with Rust, with another language. Why? Because maybe I would like to create a new interpreter with another language, not just with C, not just with Python, maybe with Rust. Okay? Because yesterday we have seen a good talk about Rust, an integration of Python with Rust. I like that. And maybe I would like to develop that. Not sure. So, about the structure of the PyC file. A PyC file is just a binary, but to get this binary file, we have to use, of course, a compiler. So with this example, with just print hello, I'm going to get this result. That's the bytecode, okay? Not the binary stuff. If I create a dump of this binary file, I'm going to get this result. Okay? You can get this result with just xdump. Xdump is a small tool on Linux where you can see on the left just the offsets, in the middle, in the center, the bytes, and on the right, the ASCII characters. Okay? But when you start to read that, if you're a wizard, maybe you can learn that the 4 first bytes, that's just for the magic number. The next ones, just for the timestamp. After that, for the size of the header and the marshaling. But when you want to analyze this kind of file, you can use some tools. In the coverage package, you have the showpy pick.py script. This script will generate a readable for humans, a description for the human. But I wanted to develop a small example, a parser and dump file. So I've used and create a new tool. just that, because I wanted to learn, okay? We can see in the description, we have the demo.py file with Python 3.5. We have the name of the file, the name of the model, and we can see just in the bottom the description of the bytes of the bytecode. Just that, okay? So that's the result. Now, in the Py file, we have a header. In the header, we have the magic number. This magic number is very useful. There's the same thing for the timestamp. These bytes are used by the interpreter to check the validation, to validate if the Py file will be used with the right interpreter and if the timestamp corresponds to match the modification time of the Python file. Okay? So, I'm going to explain each part. The first part in green is just the magic number. The next chunk is just for the timestamp. The third part is just for header size. I'm going to explain that later. For the magic number, it's not a random number, okay? There's a reason for that. In Python, we know the version of Python. Python 3.5, Python 3.6, Python 2.7, Python 1.0, okay? This version, this magic number, is based on the version of Python. I don't know if you see. Do you see? Yeah. But for the last line, we have the version, the magic number for the last version of Python 3.6. For the version 3.5.0, we have another number, 3,350. This number is used and computed to be stored in the magic number. Okay? You see the bytes in the interpreter. This value will be stored in the Py file. From that, the interpreter can check the validity of the Py file. Okay? So we have the magic number, we have the timestamp. The timestamp is just the time of the last modification time of the file. Just the example. So about the marshaling, because we have the magic number, we have the timestamps, another header for the size, and we have the marshaling. So just the objects. The marshaling is just specific to Python. It's not a standard. Okay? It's not a JSON, it's not an XML file, just a binary. It can contain some Python object. Example, a tuple, list, integer, dict, set, number, string, everything. Okay? So, when we start to learn the Py file, you will see that in the marshal.c file, there is this definition, this constant, there's constants. Each element corresponds to a type in the Py file. Example, with the code. When you write a code, the Py file will contain a type C, a type code. And the first byte will be the C byte, just the C character. You can see just the packet. If you parse this packet, you will have the type, the arg count, the keyword only arg count, the stack size, the flags of the code, of course the code, the bytecode, and for the rest, constants, the name, the var names, and the file name, and of course the name of the model. Just that. That's for the C, the type C. From my previous slide with the binary, the dump, I can see the matching. Okay? So, for the tuple corresponds to this character, just the parenthesis. So, I have a header with the type, the size of the object, and after the size, I will have a list of other objects. Because you have tuple, this tuple can contain some other tuples, list, object, dict, string, number, and whatever. Okay, for the type string, just the S. So I'm going to show just 3 examples, not the rest. Okay. But you can see that for a string, the first byte is just for the S. The size is on 32 bits, and the rest just the content of the string. Okay. For that, it's in this example, we can continue with some schema, but I prefer to use an XML dump because I would like to use it to explain to everybody, okay, if you can learn, you have your Py file, you can use my script, my tool, and it will generate an XML file. If you want to explain to some new beginners, you can use it. For example, for the header, you have the magic number. You will see where is the magic number in the file, offset 0, which was the size of the magic number, was a value in bytes, and the final value for a human. Okay? That's the same thing for the timestamp, the same thing for the size. Okay? Of course, you have the packet for the header. For the body is just the code. Okay? I don't want to explain everything, but in the middle, you can see the original string in bytes of the bytecode and the interpretation with the bytecode tag, where we can see that the first number 101 is the load name. For the next points, next segment, we can see that we have the load counts, the call function, the pop-top, load count, and return value. Okay? So you have that in the binary file. You don't have some string, just that. Maybe I need your help. Yesterday, I started this project, dumppic. Dumppic is just for the beginners. If you want to learn how to create a dump of a Py file, you can help me. I would like to create, so I need some contribution, mainly for the generation of an XML, JSON file, or just a dict. I would like to create this tool with a library, because I would like to use it with my Python project. And of course, I've started a GUI in TK, because TK is just portable. Okay, about the virtual machine now. I'm going to explain you I'm going to give you another view of the virtual machine. Firstly, we need some requirements. First, the stack. We have the stack, the frame, the core stack, and of course the bytecode. Why the stack? Because it's a basic concept in computer science. The stack is just used with, you have an element, you push another on it, and you continue, and when you want to get the last, you will pop it. Okay? It's not really difficult. Just a small example with this timeline. You have an empty stack, you will add, remove, and you can get the last element of this stack. Just with a custom bytecode. Okay? So we have the stack. I would like to have the frame, because the frame will contain the context when we execute the bytecode, your Python code. This frame has a collection of information, and of course the context of the chunk code. A frame is created and destroyed on the fly. You call a function, there will be a frame, they will have a frame, and after that, this frame will be destroyed. When you call a function, of course, there's one frame. And in one frame, you have the code object. Okay? I'm going to explain that with the call stack. For example, in this example, I have two functions, the def bar, the def foo. The foo function will use the bar function, and the bar function will execute an add. just an addition. But with the call stack, I'm going to get this result. Yeah, I have the call stack just on the left. In the middle, I have three frames. And for each frames, I'm going to have one stack. The stack for the data and the rest. Okay? So maybe we can start to discover the bytecode. I like doc. So the bytecode is just, we know that, instruction to follow. An intermediate representation of your Python code. Of course, in this case, used by the virtual machine, Python. It's a compact code coded on 1 byte. You can see the byte, because with the next version of Python, we will use 2 bytes. I see the smile. Yeah. Okay? And just there's a definition of the bytecode in the opcode.h in the header of Python. Okay? I don't have a stick to show you, but you can see that the pop-top binary head and return value have some values under 90. After 90, the bytecode can receive an argument. Okay? I'm going to explain that later. So, do you remember this example? I have the string hello, I have the string word, and I would like to concatenate them. With that, I'm going to get this bytecode. Why this bytecode? Just because that's really simple. We have 5 or 6 different bytecodes here. So in this case, I can explain everything. So inside the evaluator, we have some instruction, the load const, the store name, the load name, the binary head, the call function, the pop-top, and the return value. Just with this example, okay? I don't want to explain everything about the bytecode, about the instruction. You can go to this website and just read the instruction, okay? For the load const, that's just not a resume, a small description. For the load const, I have my constant. I would like to push it. So you have your frame, you have your code, you have the constant, and I'm going to push one thing in the constant. Okay? Is a C code in the evaluator, in the eval machine. So in this case, I'm going to get the value, and push it in the stack of the constant. Okay? For the store name, okay, I have my value, word. I'm going to store it in a variable. I will use store name. That's just the C code. I've removed some part of the code because I cannot show everything. But yeah. For the load name will push the value with the code name on the stack. Okay? That's the code, the C code. For the binary head, this bytecode is really useful because we can use it just with 2 strings or with 2 numbers. Okay? Example. It's not an example, but I'm going to read for you the C code. You have a check. If the 2 operands of the binary head are Unicode, I'm going to concatenate them. Okay. If the operands are numbers, I'm going to add them. Just that. And I will push them on the stack. I will push the result on the stack. The call function will call a function. Example, the print. Okay, the print function. Just we get the function and we call it with the right parameter. For the pop-top, I'm going to get the last element from the stack. In the C code, that just I'm going to pop from the stack. Okay? For the return value, the system will return the last value on the stack. Just that. Yeah. In this target, we have the y variable. This y variable will be used by the system to know if we are an exception, a return, a break, or a continuous statement. Okay? In fact, with the y, we can know if we are in a raise, just if we return a value, or if we use the break on the continue, or if we are in a yield. A good example, you can try to read the ceval.c file from Python. That's very useful, because sometimes you can read this kind of code. Just for the evaluation, we have one function with 2009. Sorry, excuse me. I prefer in French, but no. 2,900 lines of code. So, I think I have finished. No, not yet. Okay. Welcome to the CPython world. And just for the fun, welcome to the CPython world. Yesterday we have seen an awesome speech from Raymond and from Brett about CPython. I like CPython because I can try to do some funny stuff in the interpreter. Just for the fun, maybe, do you know the ltrace feature? No? No? Oh. This feature already exists since 26 years in the source code by Guido. In fact, you can define ltrace, _ltrace__, with any value, in this case just a string with an object, and after that the interpreter will show you the bytecode, the executed bytecode. Okay? I have this version of my computer, and there is a patch on the bug tracker of Python, just for the fun. And because we are in the Canada, and because in Montreal we have some French native speaker, there is a French version of Python. It's not a joke. I can run a demonstration, on my laptop. Okay, last thing. Since 1 year, I started with Brett, with David, Murray, and some other core dev of Python during the last CPython sprint at Montreal in 2014. I started to work on CPython. I like to use CPython. I like to help them with the review, with the patches, with the documentation. During my last talks in France, in Ireland, I tried to explain how can we start to contribute to CPython. In this case, we need you. Okay? We need you because we need some reviewers for the patch. For example, sometimes we can see some patch where the creation date is just from 6 years or 3 years, and sometimes we need some reviewers. For the documentation, we need your help. For the source code, in C or just in Python. If you're an expert in C, come on. If you're an expert in Python, come on, please. If you are a native speaker in English, please, come on. We have a job for you. A free job, of course. But we need you, okay? I'm just a contributor. I would like to continue to help when I have time, okay? And thank you.